Okay, so next what we have to calculate is the last current. Means the question will be wheel over point, means to derive wheel over point, to find wheel over point when current is contracting. So for this I'll give a formula, and that formula will be used. So that formula is sine of set to be applied, set to be applied equals to rate of current divided by vessel speed into sine of course to made good. What is course? You have to made good the angle between course to made good and rate direction of current. Once we'll come to this, we'll know how to find out. Like for example, suppose this is your formula. Like example, if you'll take, like suppose you are doing course is 0, 0, 0 degree, current is 0, 9, 0 degree, and the vessel speed required. So vessel speed is suppose 12 knot, current is 4 knot. So the set to be applied. So sine of set to be applied equals to rate of current 4 divided by 12 into sine of course to made good. So course to made good is 0, 0, 0. So 0, 0, 0 in direction of current. So 0, 0, 0 and 0, 9, 0. So means that angle between both is 90. So sine 91. So this one become 4 divided by 3, 1 by 3. So it will become 1 divided by 3, 0.33. 0.33. So value will become 0.33. So sine inverse of answer was 2. So 19 point. So course to be set to be applied. Apply that. Set to be applied. Applied is 19.47 degree. So like you had to follow this. We can write this one as 5 degree simple. 19.5 degree. So as we know, we are going something like 0, 0, 0 and current is from this direction. So current will push your vessel in somewhat in this direction. So we'll have to apply the set in opposite direction. So how much we have to apply is 19.5. So as we have to go 0, 0, 0 and this set we have to apply it means 360 minus 19.5 means we have to do 340.5 degree. This is the course. Is correct? Yeah. So 340.5 degree we have to calculate. So this is the application. Now we'll calculate the we are going to calculate the how to find out the wheel over point. And for that we'll take an example that will be better for your understanding. So what we'll take, the question is, suppose first course is like this one is 090 and second course is suppose 030 degree. So this angle will become 60 degree. So this is 120 degree. And suppose current is 135 degree. It is 125 degree into 4 knot. This is the rate of current. And the question given is vessel length is suppose 330 meter. V is 12 knot. A radius what we have to follow is 1 nautical mile. And suppose and then theta is already 60 degree. So now for this one we have to calculate. So for this one what you have to do is first you find out the wheel over point, as without just ignore this current and find out this wheel over point, as we have already discussed in last class how to find out, that is f plus r tan theta by 2. So once you have calculated this, so now apply this formula for both course. So first course is 090. So sine set to applied equals to rate 4 rate of current is 4 divided by speed is 12 into sine of angle between cos to made good. So cos to made good is 090 and the current direction of current is 135. So the angle between both will become 45 degree. 45 degree. So if we calculate the value of this, it will come 4 divided by 12, 0.33 into sine 45 degree in shift sine inverse 13.6. So that is 13.6 degree. So this is the set which you have to apply. Like suppose we have to follow this 090 and current is from this side, so it will try to divert the vessel in this direction. So the course which we have to apply it in the opposite direction. So whatever the course, so this set we have to, so 90 degree minus 13.6, so 76.4 degree what we have to do actually because of this current, so that we can follow this track. Okay, now we'll calculate the same for the second track also. So this is for the first leg. Now for second leg again same sine set to be applied 4 divided by 12 sine. Now the angle between second course and current, so this 135 and that is 30. So the angle between both will become 135 30 no, 105 degree, yeah, 30 degree, no? 30, yeah, 105 degree. So this one become divided by 2 into sine of 105 degree shift of sine inverse. First to say it is 18.8 degree set which you have to apply. Again you have to go in this direction. You have to go in this direction and current in this direction, so you'll have to apply somewhere in the same direction where the current is. So this much I do set to be applied. So what course we have to do is 30 minus answer 11.2 degree for this one. If we will do the 11.011.2 degree, then we'll follow this course. Now what we have to do is we have to see how much actually. Now this is not your course. Now no more 090 and 030. So now the new one is 076 and 011. So how much is the course to be altered? So course to alter, how much helmet means what is the theta between both. So this is the difference between both. So how much it will be? 76.4 minus 11.2, 65.2 degree. 65.2 degree helm. 65.2 degree we have to actually alter. Now suppose we are doing this 12, so we'll calculate the rate of turn. Rate of turn will V upon R, so 12 degree per minute. This is the rate of turn we have to calculate. So suppose in 1 minute it is going 12 degree. So for 65, so for 65 degree how much time it will take? इसलिए for 65 degree, for 65.2 degree time required 65.2 divided by 12, so near about 5 minutes something, just assume 5 minutes. It is taking 5 minutes. Now this 5 minutes you will take to turn, means once you will apply the helm it will take 5 minutes to come to the final course. So for that 5 minutes how much this current will affect you, that we require to calculate here. So the rate of current is 4 knot. So in 5 minutes how much? So in 60 minutes 4 nautical mile. So in 5 minutes 4 divided by 60 into 5, that will become 20 divided by 60, that will become 0.33 nautical mile. Now we have calculated both things. Now what we have to do is we have to plot a current from the original wheelover point in the opposite direction. Like current is in this direction, we'll just plot in the opposite direction here like this, and we'll cut this value 0.33 on this one. So 0.33 nautical mile will cut on this one. in the opposite end, like current is in this direction, so we'll go in the reverse direction, and we'll cut 0.33. Now thereafter what we have to do is we have to transfer the final course from the point where it is 0.33. So we'll transfer this line here. Suppose I'm transferring this one, final course here, transferring this one. Now this I'm just rubbing this one, just rubbing this, so because we have something to discuss here. So this one is parallel to this one, so the point where it will cut the original line, this will become your will over point with current. This will become your new will over point. Now since the current is coming in this direction, you will not have to start the will over giving help from this point. Instead of this, you will have to give the help from this point. Once you start the giving help from this point, because of the current, it seems like will be turned already, but no, because of the current you will drift in this direction and continuously will follow. Suppose this was your first rate of turn. So because once you will start from here, turning like this, and because of current you will not follow this, but you will move on this track only, So this is what we had to this was the procedure how to calculate the will over point with current. So for this one it is better to write the step, what step to be followed. So there are 4 5 steps there. So calculate the point number 1. Point number 1, calculate the will over point without current. How to calculate will over point? That is f plus r tan theta by 2. So for the example what we have given is f is, we have taken 330 meters, so 330 18 52 plus r we have taken 1 into tan, and theta is 60. So sorry, this theta between this both, so 120. So this will become 120 divided by 2, so this will become 60. So 330 divided by 1852, so 0.178, just take 0.18 plus tan of 60, tan 60 degree is 1.73. So this will become 1.91 nautical mile. So this is 1.91 nautical mile. So just first to calculate this will over point. Thereafter calculate the now the second step is find how much time vessel will take to turn, what we had calculated for both leg. So that time, then calculate the current for same interval. Now the third step, draw a line reciprocal to the current, from will over point. From will over point. Then mark, just write mark the value of current on line drawn in step 3. Then what to draw a parallel line to final course from step 4 is what we have calculated here from there. And then the sixth one is extend that line and let it cut the initial course means let it cut this initial course means this one. And the second final, the intersection point will be the final spillover point with current. So this is what all about the applying the current. One thing I would like to suggest you, if you are reading the notes of Satish for your exam preparation, so I will suggest you that, because there is when I was studying, I found that there was a correction. So let me take that book. Yeah, so if you'll see in this question number 40, yeah, in question number 44 in Satish's book, in question number 44, where we have to apply the current. So here one mistake is there, just a correction, because in Satish I have seen he is always using that formula to calculate, because he was calculating the distance of, because in that question what is given is we have two waypoints. So waypoint is given and your vessel is somewhat distance 6 miles away. It is given 6 miles away, and then it is asking when you will apply the wheel over when we'll apply the giving helm, means we have to find the wheel over line. But instead of following the formula, he has followed the formula. What he had followed is, he has followed r1 minus cos theta plus f sin theta. But we have already explained that this is the perpendicular distance and not this distance. So this is not correct. Actually we have to find, because this is 6 nautical mile and we have to apply after how many miles we have to apply wheel over points. So we just have to calculate this value, and since we know this is 6, if we'll calculate this value, so we'll know this value, and after moving that much value we'll start giving help. So don't use this formula, this is wrong. Just use f plus r tan theta by 2, what we have already calculated, because that is the distance which you required here. So whatever will get there in this question, it is given 160, speed is given 18.8. so and theta second turn, okay, so here will be theta will become 235 minus 160, so 75 degree, and this v is given 18.8 knot. So rate of turn will become r, how much radius, rate of turn is okay, so rate of turn is given here 10 degree, so it is given 10 degree. So apply that, r will become v 18.8 divided by 10, so r will become 1.88. r we can find out. Then to find out the distance, we'll find out the distance, means we have to find out the wheel over point from wheel over point from this waypoint. That distance we need to calculate. So according to our formula, as suppose Satish is also taking 0.2, I am taking 0.2 now, and r is 1.88, and 10 theta by 2 become 75 divided by 2, so that value will come 1.64 nautical mile. So the value is distance of wheel over point is 6 minus 1.64, that will become 4.36 nautical mile, and he has taken this 1.6. okay, value is not much because the alteration is not much. If the alteration will too much, means if the angle will be more, then the value will be vary with large value. So the concept should be right, because we'll have to follow this one, and this one will not get the correct answer. So for this particular question is not much difference in the answer, but the concept is not correct. So just 4.36. So 6 minus, yeah, 4.66, because this value is 1 point, sorry, 1.64. So after moving 4.36, we will have to start giving help. So this was a correction I found during studying this notes. I was also following the same notes, but that was a correction. So I think this is all about the rate of turn. And after getting this much of derivation, once you know this much of derivation, how to calculate, how to derive the particular things, I mean distance, here we have to find out only the distance from particular point to particular point. And this is the one important thing, the question has also been asked in the MMD exam. So you, and this is the best one to find out, because if you're going to draw the current diagram, that will be very lengthy, and you'll have to apply, means it will take time. But here it is very simple, just apply this formula and it will be very easy for you to find out the available point with current. So thank you, this is all about this video, rate of turn. And hereafter, actually I'm also preparing for the oral exam, so I don't have much time. Otherwise I wanted to make video on magnetism, so we'll try if I will find time, because I think magnetism is a very easy topic, and if you have some little bit concept is required, and thereafter it will be a very easy topic, and you will be securing your 25 marks 100% sure. So I will try to make the video on that also. But for now, this is all about rate of turn. And thank you for watching this video, and please like and subscribe the channel.